Hello. So here I need to compute 1 divided by the magnitude of d. So this is the same thing as 1 divided by because that is the magnitude of d. Square the first component, square the second component, add the two together, then find the square root. So this is the square root of 4. We have 1/2. So here we have so since we're adding these parentheses, they don't matter. Okay, so we have 2 plus 5 plus 6. That is 12, no, 13. And then we have 3 plus 4 minus 1. So we have 6 minus 1, sorry, 7 minus 1 is 6. Okay, this is the magnitude of 4b plus 5c. Interesting number. It's not divisible by 3, not 4, not 5, not 6, not 7, not any even number. Well, now I'm curious. Is that a prime number? So when I put it in the calculator, it is in between 51 and 52. So we need to test all of the factors, all of the prime factors up to 51. So it's not divisible by 2, not 3, not 5, not 7, not 11, not 13, not 17, not 19, not 23, not 29, not 31, not 37, not 41, not 43, not 47. Look at that, 2621 is a prime number. To determine whether a number is prime or not, take the square root of it. So it's radical 2621 is in between 51 and 52. And then we need to find all of the factors up to 51. If none of those factors divides evenly, then you have a prime number. And I skipped 4 because 4 is composite of 2. I skipped 6 for the same reason. I skipped 8, I skipped 9 because I had already determined those up in here. So I tested all of the prime numbers up to 51. None of them divides evenly into 2621. Therefore, 2621 is a prime number. And that's the magnitude. That's the size. Okay. Here I would distribute the negative. (15 minus a negative 8 is 15 plus 8. Let me pencil in what I'm doing here. The magnitude of the vector is the sum of the two squares square rooted. Interesting. Is 673 prime? So does 2 divide into it? No. Does 3? 10? No. 5 does not. Does 7? No. 11? No. 13? No. Look at that, another prime number. Okay. So you have a scalar multiplied by a vector, distribute the scalar in. And then rationalize the denominator. Here are the parentheses. You can take them or leave them. It does not change the problem. So we have 2 minus 5 minus 6, negative 3, negative 9, and 3 minus 4 plus 1 gives me 0. 3 minus 4 is negative 1, plus 1 is 0. Okay. So what's going on here is it's x1 plus x2, and then y1 plus y2. And here we have x1 minus x2, y1 minus y2. These magnitudes are both being squared. What's going on inside here is if you just look at the magnitude of the vector 2, 3, this is going to be the square root of 4 plus 9. The square root of x squared plus y squared. So this is going to be the square root of 4 plus 9. When you square a square root, you eliminate the radical. And the scalar comes along for the right. Okay. So then when we minus this other magnitude of a vector being squared, that's why we have 25 plus 16. All of that times by the negative 2. No square, no radical. Same thing's going to happen here and here. Square the first term, square the second term. The absolute value, the magnitude means square root, and then square that. The radical goes away. Negative 3 squared is 9, plus 1, minus 4 plus 9 is 13. 2 times 13 is 26. And then minus 25 plus 16 is 41. 41 times 2 is 82. I'm going to use my calculator for this. Express each vector in terms of the unit vectors I and j. All right, well, this is 4i and then minus 2j. This one is negative 9i, and I'm going to leave it at that. There could be an argument that this would need to be negative 9i plus 0j, but I'm good with just the first one. Here, okay, 20 minutes into the video. This might be long. Thank you. Please go to tutoring.